Alright, page 3 here. Find all solutions to the system, then give one solution to each. Okay, so remember that all that means is that we're going to be graphing this, and then any point in the shaded region is a solution. So, first point, our first line here, we are going to just graph this because it's graphable. Minus 1 here, up 5, 1, 2, 3, 4, 5 over 2. I could also go down 5, 1, 2, 3, 4, 5, left 2. Okay, this is going to be a dotted line because it is just less than, it's not or equal to. Dots. I wish my dots were straighter. Alright, the next line here, we have 6x plus 3y is greater than 9. I'm going to put this in slope-intercept form, but getting y by itself. So subtracting 6x from both sides. So I have 3y is greater than or equal to negative 6x plus 9, and then divide by 3, y is greater than or equal to negative 2x plus 3. So uno dos tres, down 2 over 1, down 2 over 1, and continue to do that. Okay, up 2, left 1, up 2, left 1, and in this case it will be a solid line. Solid line because it's or equal to, right? So that shows that our solution can happen on our line. The dotted line shows that our solution cannot happen on that line. Alright, so completed that. Now let's think about the shading. For our dotted line, it was y is less than, and so that means we would shade below our dotted line. Okay, so below our dotted line on this half of it. Okay. For our solid line, it says above, so we have to shade above the solid line, below the dotted line. That's going to be this region. Okay, so a solution that's in this region, we'll say 6, 0. 1, 2, 3, 4, 5, 6, somewhere over here. That's the solution. Okay. Second line, we have x is less than or equal to negative 1. Remember that x equals is going to be a vertical line at negative 1. So here's one place where x is negative 1 is at negative 1, 0, negative 1, 1, negative 1, negative 1. Solid line straight up and down here. Okay. Okay, as we think about this, we can say, okay, does 0 work? If we plug 0 in here, is 0 less than or equal to negative 1? And the answer is no. 0 is greater than. So we wouldn't shade to the right, we'll shade to the left side. Okay, keep that in mind. Let's try to put this in slope-intercept form. Okay, so we're going to subtract 6x from both sides. And so we're left with negative 8y is greater than or equal to negative 6x. Divide by negative 8. We divide it by a negative number, so we have to flip the sign. And that becomes a positive 3/4 x. Okay, so solid line here. Our y-intercept is 0. We go up 3, 1, 2, 3, over 1, 2, 3, 4. We could also go down 3, left 4. Solid line through those points. Okay, because it's or equal to. Okay. So we already know we're shading to the left side of our vertical line. And now as we look at this, it's less than. And so that means we would shade underneath this line, left side of the vertical, underneath this other solid line. This is our region that we're shading. So if we think about the solution, negative 2, negative 3. Okay. Alright, solving some problems here. Just a little bit more involved than the first page. So we'll just go through it here. Minus 6 equals 3x minus 6 plus 4x. Okay, combining like terms here. 7x minus 6 equals 7x minus 6. At this point, we should recognize we have the same thing on both sides. This is infinitely many solutions. Okay. You could solve it all the way down to you get to the point where 0 equals 0, but it's infinitely many solutions. Again, the directions here tell us to solve for x. So for 24, we're going to solve for x. We're going to get x by itself. So I'm going to multiply both sides by n. x plus g equals 7n. Get x all the way by itself. I'm going to subtract g, so x equals 7n minus g. 25 is an absolute value equation. I'm going to add 7 to both sides. 2 times the absolute value of x plus 4 equals 10. Divide by 2. So then absolute value of x plus 4 equals 5. Absolute value is positive, so we can continue. We have to split the problem. X plus 4 can equal 5, but x plus 4 can equal negative 5, because that's how absolute values work. And then we just solve both of those, and both of those solutions are our solution. So x could be 1 or negative 9. Don't put parentheses around that because it is not a location, it's just separating our two solutions. Number 26, cross multiply. 4 times 6x minus 3, 9 times 3x. So we get 24x minus 12 equals 27x. I'll subtract the 24x from both sides, and I get negative 12 equals 3x. Divide by 3, x equals negative 4. Number 27, we're going to distribute here. Remember that you're distributing a negative 4. Okay, a lot of people remember it the first time, but then forget it the next time. So it should be negative 20 here. Combine our like terms, we get 2x minus 20 equals x. I'm just going to subtract 2x from both sides. I get negative 20 equals negative x, and divide by negative 1, so x will equal positive 20. Number 28, we're solving for x still, as the directions told us, so I'm going to add a to both sides here. 8x equals a plus b. Divide by 8, and I'm just going to have to leave it like that. X equals a plus b over 8. 29, again, cross multiplying, making sure that we distribute as we do so. So 9 times 2x plus 3 will equal 6 times 3x minus 2. So 18x plus 27 equals 18x minus 12. Right here I can kind of see what's going to happen, but I'll play it out. Subtract 18 from both sides, 18x from both sides, and I get 27 equals negative 12. Okay, this is like the opposite of number 23. In number 23 we said, hey, we have two things, all of our variables are gone and we have a true statement. Here all of our variables are gone and we have a false statement. This is no solution. 27 does not equal negative 12. No way we can solve that and get a solution. Alright, number 30, trying to get x by itself again. I'm going to start by getting rid of this fraction. We can do that by multiplying by its reciprocal. So xw equals 5y over 3. I want to get w by itself, so I'm going to divide both sides by w. And so what I have is x equals 5y over 3w. And finally, we'll end number 31, another absolute value equation. Okay, so we're going to subtract by 8. Remember, with the absolute values, we want to get the brackets by itself before we work anything inside of them. You can never distribute to an absolute value bracket. So negative 3 times the absolute value of 2x plus 1 equals negative 3. We'll divide by negative 3 on both sides here. So the absolute value of 2x plus 1 equals 1. And now we'll split this problem. 2x plus 1 can equal 1, or 2x plus 1 could equal negative 1. As we solve, 2x equals 0, so x could equal 0. 2x could equal negative 2, so x could be negative 1. Our two solutions there.